So here's the thing. Imagine an AI, right? Super advanced.
Yeah, go on.
It can write symphonies, churn out amazing code, make images that look totally real.
Okay, the kind of stuff we're seeing everywhere now. State of the art.
Exactly. But then you show it like a picture of a totally normal analog clock.
Like on my wall right now.
Yeah. And you ask it, what time is it? And it kind of struggles or just gets it flat out wrong sometimes. Or show it a calendar page, ask it what day the 153rd day of the year is, and nope, wrong date.
It sounds like a weird little glitch, doesn't it? Like, okay, I missed that one thing.
That's what I thought. But it turns out this isn't just some random error. There's actual research showing this is a consistent problem, even for the biggest, best AI models out there.
Right, it's a documented blind spot. Fascinating, really.
And that unexpected limitation AI getting tripped up by visually reading time, that's what we're digging into today.
We've got a bunch of material here, but we're really focusing on this key study from the University of Edinburgh. They looked right at this.
Yeah, so our mission, you could say, is to unpack why. Why does AI find this visual time stuff so hard? What does it mean for, AI in the real world?
And maybe what it tells us about intelligence itself? How AI thinks versus how we think about time.
Okay, let's get into it. And just to be clear, we're talking about visual-temporal reasoning, fancy term, but it just means understanding time from what you can see.
Like a clock picture or a calendar image, not just processing time data, but seeing it.
So the big finding, the headline from the research we looked at, is that these really advanced AIs, especially the ones that handle images and text, the multimodal ones.
MLLMs, yeah, multimodal large language models.
Those ones, they do surprisingly badly when you ask them to figure out the time from, like, a picture.
Yep, that's the main point from the Edinburgh study. It was called Lost in Time. Clock and Calendar, Understanding Challenges in Multimodal LLMs. Really spells it out.
And this wasn't some obscure model test either. They used the big names.
Oh yeah, Jubal D4.0, Gemini 2.0, Claude 3.5, Sonnet.
The ones everyone's talking about. And a strong open source one too, Llama 3.2 Vision.
Right, and to really test them properly, the researchers didn't just grab random images, they built specific test sets.
Okay, what were they?
One called Clock QA, loads of different analog clock faces, different styles, the works, and calendar QA images of yearly calendars and then questions about them.
So the clock results.
Yeah.
How bad was it?
Pretty striking, actually. The data showed that even the absolute best model, it only got the time right from the hand positions less than 25% of the time.
Less than 1 in 4.
Seriously. And it got even worse if the clock had, say, Roman numerals or really fancy stylized hands. Made it harder.
Okay, that makes some sense. Visual clutter, maybe?
You'd think, but here's a really interesting bit. They tried removing the second hand, thinking maybe that was confusing it.
Did it help?
Nope. Didn't really improve things. Which strongly suggests the problem isn't just about spotting the hands in clutter.
So it's deeper.
It seems to be, yeah. Like a fundamental issue with correctly identifying which hand is which, figuring out their exact position, the angle, and translating that angle into a number.
Right, it's not just seeing lines, it's that whole spatial reasoning plus number conversion.
Yeah.
And the calendars, did they do better there?
A little better, but still not exactly a success story. The best AI still made mistakes on date calculations about 20% of the time.
1 in 5 errors. And these weren't just read the date questions.
No. They involved things like finding holidays based on their description or calculating, like you said, the 153rd day, stuff that requires understanding the calendar structure and doing some math based on the visual layout.
So it really comes back to that paradox you mentioned at the start.
Exactly. These are tasks most kids learn pretty early on, right? Telling time, using a calendar. Yet these super sophisticated AIs that can do incredibly complex things, they stumble here.
Okay, so that's the what. They struggle. Let's try to get into the why. Using, like, first principles thinking, breaking it down like the researchers did.
Well, a really fundamental point is that AI models don't have, a body or a biological clock. They don't experience time passing.
Right. No internal sense of seconds ticking by.
Exactly. They work with data about time, timestamps, durations, if you feed it the data in the right format, or let it access a system clock or an API, it can process it fine. It can calculate, schedule.
But that's like time awareness through data, you're saying.
Yeah.
Not the same as looking at a clock face and reasoning about the time visually.
Precisely. That visual temporal reasoning is a different beast.
Okay, so let's break down the clock reading task. Why is that so hard from just a picture? It seems simple visually.
It seems simple to us, but for the AI, it's actually a really complex mix of skills.
Like what?
Okay, first, basic visual perception. Identify the circle, the numbers, the hands.
Step 1, see the parts.
Then, spatial awareness. Where are the hands pointing in relation to each other, and the numbers, what are the angles?
That spatial bit sounds tricky.
It is. Then, context. Knowing the shorthand is hours, the long one is minutes. That's not explicit in the image, it's learned knowledge.
Right.
And then you need mathematical reasoning to translate those positions and angles into, 3.15.
And the studies show they fail where exactly?
The weak points seem to be accurately judging the hand positions, especially the precise angle, and then making that leap, converting the visual spatial info into the correct numerical time. That's where the reasoning falters.
Okay. What about calendars? The info is printed right there. It seems more straightforward than angles.
It seems like it, but again, it's not just reading numbers off a grid. It's reasoning about that visual structure.
How so?
You need the visual pattern recognition to understand the grid layout itself, then numerical counting. But also, knowledge of calendar rules, months have different lengths, days of the week cycle, leap years exist.
Okay. Rules that aren't visually obvious on the page itself.
Exactly. And then you need the computational reasoning to answer questions that require calculation, like finding the date of the third Monday in January or calculating day 153. You have to use the visual structure plus the rules plus math.
And the research mentioned something about how AI does the math part differently too, not like a calculator.
Right. This is key. A normal computer, or a person doing math, follows a strict step-by-step algorithm. Add this, carry the one, etc.
Okay.
These big AI models, especially LLMs, often work differently. They're essentially predicting the most likely sequence of numbers based on all the text and data they've seen. It's pattern matching.
So for 2 plus 2, the pattern equals 4 is so incredibly common it gets it right.
Almost always. But for something complex, like calculating a specific date from a calendar image or figuring out the exact time from fuzzy hand angles, relying purely on learned patterns is less reliable. It doesn't follow logical steps in the same way, so it can be inconsistent.
And I guess rare things, like leap year calculations, might not show up often enough in the training data patterns for it to learn reliably.
That's also part of the issue the sources point to, yeah. Limited exposure to less common temporal patterns makes the pattern matching approach weaker for those cases.
Okay, so this difficulty with clocks and calendars, it points to something deeper, doesn't it? Beyond just time.
It really does. The study highlights this gap. AI is amazing at tasks where it can lean heavily on statistical patterns learned from massive data.
Like predicting the next word in the sentence.
Exactly. But it struggles when tasks require genuine generalization or abstract thinking or, and this seems crucial here, smoothly, combining different kinds of reasoning.
Visual plus spatial plus numerical plus context.
Yeah.
All at once.
Yes. It sort of highlights that AI fundamentally is often a very sophisticated statistical prediction machine. It matches patterns. It doesn't necessarily have a deep intuitive understanding of the concepts underlying those patterns.
Like the concept of time itself.
Precisely. Remember that example is mentioned in the sources, too, about AI image generators when you ask them to create a picture of an analog watch?
Oh, yeah. They often show the time as 10.10, right?
They do, because that's the standard pose in watch advertisements. It's a super dominant visual pattern in the data they were trained on.
So the AI isn't thinking, let me set the time to 10.10. It's just thinking, watches usually look like this.
Exactly. It's pattern reproduction without real comprehension of time or how the hands represent it. A perfect example of the difference between mimicking patterns and actual understanding.
And the implication is that just throwing more data at the problem might not fix this fundamental thing.
That seems to be the suggestion. Simply scaling up current models might not be enough for this kind of integrated reasoning, which is why some researchers are exploring totally different avenues.
Like what?
Well, one approach mentioned is temporal graph learning, TGLLM. The idea is to try and represent time relationships more explicitly, like in a map or graph structure within the AI.
So make the connections between time points clearer, not just hope the AI infers it from raw data.
Kind of, yeah. Hoping that a more structured representation leads to more robust reasoning. It suggests we might need new AI architectures altogether for these kinds of challenges, not just bigger versions of what we have now.
Okay, stepping back a bit. Why should you, listening right now, actually care if AI can read a clock face properly? What are the real-world consequences of this temporal reasoning gap?
Well, think about all the places we want to use AI that involve time. Scheduling assistants may be reading meeting times from an image of a whiteboard.
Okay.
Autonomous robots or self-driving cars need to operate precisely in time-sensitive situations. Interpreting visual cues related to time could be critical.
Like reading a temporary road sign with operating hours.
Potentially, yeah. Or accessibility tools trying to describe the visual world for someone. Or even healthcare systems monitoring patient data streams where timing is everything. Reliable temporal understanding is pretty crucial for those.
Right. If the AI misreads the time from a visual cue or messes up a date calculation based on a calendar image, that system becomes unreliable.
Exactly. Best case, it's annoying. Worst case, well, it could be genuinely problematic or even dangerous, depending on the application.
It also really throws the difference between human and artificial intelligence into sharp relief, doesn't it?
Absolutely. Things that become almost second nature to a human child through experience glancing at a clock, understanding days of the week, are proving remarkably hard for AI systems that can outperform us in purely computational or pattern-heavy tasks like chess or protein folding.
So the big lesson from the research here seems to be caution.
Definitely. When a task mixes perception, like seeing an image with precise, flexible reasoning, you really can't just assume the AI's got it right.
These rigorous testing, fallback plans.
And often still needing a human in the loop to verify or handle the exceptions. This whole study is also a great reminder for us to think critically about what AI can really do.
How so?
Well, just because a model seems superhuman at some complex tasks, it doesn't automatically mean it's reliable for things that seem simple to us, especially if those simple tasks require knitting together different kinds of thinking.
Like the visual, spatial, numerical, and context combo we keep coming back to for clocks.
Exactly. It pushes us to question the outputs, especially when genuine understanding matters more than just finding the most statistically probable answer.
It's interesting to think about this using fictional characters, too, like archetypes of different kinds of intelligence.
Yeah, that's a fun way to frame it. Take someone like Sherlock Holmes, or maybe Data from Star Trek pure logic machines, right?
Right, all deduction.
If you gave them the raw data, hour hand is on the 3, minute hand on the 12, they'd deduce 3.0 instantly. But would they intuitively grasp what those visual positions mean on some weirdly designed clock face without having seen it before or being programmed explicitly for it?
Maybe not. It mirrors the AI being good with data, but struggling with that visual interpretation, that joining of different modes.
Or think of an action hero, someone with amazing spatial awareness, reacting instantly to their environment.
Navigating chaos.
Yeah, that relies on seamlessly integrating vision and spatial reasoning in real time. The very thing AI seems to struggle with when judging the precise angle between clock hands.
And then compare both of them to how a kid learns to tell time.
Right. It's not just logic or spatial skill. It's embodied experience watching clocks, associating time with meals or bedtime, maybe playing with a toy clock. It's integrated learning. Visual, spatial, temporal, even social cues, all mixed together.
Which is totally different from how AI learns from these huge static data sets. It lacks that lived experience.
And it really makes you wonder, how does our human intelligence manage to weave all those threads, visual, spatial, numerical context together so effortlessly for tasks like this? And why is replicating that specific kind of integrated intelligence proving so hard for AI? It's a deep question.
Okay, so let's wrap this up. The key takeaway from this deep dive seems to be that AI's surprising difficulty with reading clocks and calendars from images isn't just a minor quirk.
No, the research strongly suggests it points to something more fundamental. It stems from AI operating mainly as a pattern matcher. It struggles in smoothly combining different reasoning types, visual, spatial, numerical, and maybe limitations in how temporal concepts are represented in its training.
So, based on all that, especially the challenges, the research flags the need for potentially new architectures, not just more data. What's your bold prediction here?
Okay, bold prediction time. I think while AI will definitely get better at these specific tasks, achieving that truly human-like, intuitive, visual, temporal understanding.
The kind where you just glance at a clock and know the time without thinking.
Exactly. That seamless grasp of time represented spatially and numerically, visually. I predict that's going to remain a really tough, fundamental hurdle for AI for at least the next decade. It's going to need some significant breakthroughs in AI architecture, moving beyond the current dominant approaches.
That's a strong prediction. It
Yeah.
really makes you think. And it leaves us with a really interesting question for you, the listener. As AI gets woven more and more into our daily lives, our schedules, navigation, everything, how much do we actually need it to understand time the way we do? That deep, intuitive, integrated sense.
Or is it maybe enough if it just gets incredibly good and reliable at handling the time-related data we feed it, processing timestamps accurately, following scheduling rules perfectly?
Where's the line? What stands out to you after hearing about this deep dive into AI's temporal blind spot? Something to chew on.